Algebra 1, Day 8, Domain and Range of Continuous Functions. So first, let's identify something about these types of functions. So whenever somebody says a continuous function, that just means that all of the points are connected. So that means that it's not going to be just a bunch of separate dots on our graph. They're all going to be connected to each other. So in the same way that with those dots that we saw on the graph, we could run the vertical line test in order to figure out if it was a function or not. We could do the same thing with these continuous graphs. So what I like to do is I take my pencil and I grab it and I run it all the way across my graph. I say, oh yeah, that's definitely a function. I don't see it touching twice anywhere. Okay, let me try this one. That's definitely not a function. It's touching twice there. So I set my pencil aside. I go ahead and write a F here for function. And that little symbol to tell me, no, it's not one. So we can use the vertical line test, vertical line test, to figure out if a graph is a function. So they asked us which graph. I went ahead and told you that. So the graph on the left, that's the green one, is a function because it passes my vertical line test. However, the guy on the right, he's not a function because he failed my vertical line test. His graph touched twice. So in the same way that we can take the domain and range of those graphs that we saw before, or the mappings or tables or other various things like ordered pairs, we can also take the domain and range of these. And what I want to say before I even get started on this is I'll say the domain and range are simply the limits, okay? For domain, it's how far left and how far right. What's the furthest left and the furthest right that graph can go? For range, it's the furthest down, the furthest up. Why is that? Well, domain is x, right? X-axis runs from left to right. So I want to know how far does it stretch out on that? Range is y-axis, up and down. So I want to find out how far it stretches down and how far it stretches up. So let's go ahead and start filling these in. So my domain is a set of all possible x values of a function. Other names for domain are x values, input, and independent variables. Range is a set of all possible values, y values of a function. Other names are output and dependent. So last time we talked about discrete functions, which meant just a bunch of points, random points, okay? But continuous means connected, meaning all those points are connected by some form of a line, a curve, something. So functions, all connected values within an interval. So there are no gaps or holes. We use this type of notation called interval notation, meaning we're going to use those fancy inequality signs. So what they're going to do is they're going to show all the numbers that are included since there are no gaps and holes. So instead of us listing out the numbers 1, 2, 3, 4, 5, 6, 7, instead I would say the domain went from 1 to 10. The range went from -5 to +5, okay? So let's take a look at the symbols. So first of all, on a graph, if the graph ends somewhere, we can have a filled-in dot or not filled-in dot. This one is called closed. I call them filled. And this one's open. And this is unfilled. So the inequality symbols that go with this one are the guys that have that extra line, meaning that the x and the y are possibly are at that point. However, the one that's here means that this point does not exist on the graph. It stops right before it gets there. So we will not be using that extra line. So let's go ahead and try this with an example. So there's lots of different ways to do this. I never really got a very good explanation for it while I was in school, but the best system that I've come up with is just kind of going one by one. So first thing I ask myself is this discrete or continuous? Well, I notice that all these points are interconnected here, so I'll say this is continuous, meaning that it's going to be set up like this. So I'm going to have to ask myself, what's the domain? What's the range? So some people have ID cards, some people use their pencils, other people use rulers. Totally fine, whatever you want to use, but I'm just going to draw lines to show you, okay? So first thing we're dealing with here is domain. My domain is my x value, so I'm going to highlight that axis. Now I'm going to look, where are my x smallest? Well, they are smallest out here, over here on the negative side. So what I'm going to do is I'm going to take my pencil here, and I'm going to run my pencil all the way across until I hit the very first part of the graph. Now, that first part of the graph, I'm going to see where it lines up on the x-axis, and it lines up perfectly on -2. Okay, so I got that. However, I have to look at this dot. Is this dot filled in? Yes. Extra symbol. Okay, so I got that one. Let's get that out of the way. So now I'm going to use a different color. I'll use orange here. So now I'm going to start over here at the positive side of the x, noticing that the negative side went over here, positive side went over there. Okay, so I'm going to start over here. I have my pencil again. I'm going to keep moving until it gets to my graph. I'm going to look to see where it hits the graph. It looks like +4. So I ask myself, let me look at this dot here. It is not filled in, so I will not put my extra symbol here. There is my domain. Let me write it out just a little bit prettier. Okay, we got it. All right, let's do our range now. So I'm going to clean this up. Okay, so now I'm going to deal with my range. I'm going to go ahead and highlight that one in blue. All right, so now I'm going to go ahead. I'm going to choose another color. I'll use this pink here. I'm going to go ahead and take my pencil and I'm going to face it this way. First thing I'm going to do is I'm going to run it from the very bottom of the graph, and the reason is because y's are smaller here. So I'm going up. I touch the graph right there. All right, I stopped. I'm going to see where it hits that y-axis. It looks like a -3. Then I take a look at my dot. It's filled in. So I'm going to put my extra line. All right, got that. Okay, so now that I have that, I'm going to go ahead and do the same exact thing at the top. I'm going to draw this brown line here. That's going to be my pencil. I'm going to run it down. Boop, and it hit. So it looks like it's y equals 3. But I look at my dot. Is it filled in? No. So that means that I'm going to leave it just like that. All right. So now I have a domain and range. So the way that I would read this is I would say my domain is -2 is less than or equal to x, which is less than 4. You can also say my domain runs from -2 all the way up to, but not including, 4. Okay, so let's go ahead and determine if this is a function or not. Let me draw my pencil here so we can do our vertical line test. I'm going to run it across. I'm looking to see if it touches twice. And it did not. So this is a function because it passes my vertical line test. Okay, got that. Next one, domain and range. Okay, same thing again. First thing I say is, okay, is this continuous or is this discrete? This is continuous. I see all of them connected. So I'm going to start off by writing in the center part of my domain and range. Okay, so now let's go ahead and deal with the domain first. Again, my domain is my x's. So I'm going to go ahead and draw my pencil in, or actually I'll go ahead and grab it from up here. Okay, so I'm going to start over here where my x's are smallest, and I'm going to run it all the way across. So I'm going to go, and it touches my graph at -4. Let's go ahead and write in that value. All right, so I'm going to look at the dot that's associated there, and I say, oh, that's filled in. Let me go ahead and write in my extra line. All right, got that. Now let's go ahead and do the same thing to the other side. Go, and it hits right there. That's where the graph ends, the limit of it. So now I'm going to say, oh, well, what number is that? Well, it looks like +1. I look at the dot. It is not filled in, so no extra symbol. So I'm good with my my domain now. All right, got that. So now let's go ahead and do the same exact thing for my range. That's my fancy y-axis. Now, do not get yourself confused, because notice how this graph curves around. It still doesn't matter. Whatever's the lowest point, even if it's not at the start of the graph, the lowest point is here. Why just put this X? Do not confuse yourself and think you have to go back up to that point. It doesn't matter. Whatever's the very lowest is what we consider our range. So let me go ahead and draw in my pencil. Let me use red. Okay, here's my pencil, or whatever tool I'm deciding to use. I'm going to run up, and I hit -7. I'm going to go ahead and write it in my first spot. I look at this. Do I see a dot? No. Okay, so what does that mean? Well, that means that it's filled in. We consider that to be filled in. Unless we actually see an empty circle like this, we consider that filled in. So that's going to be an extra line. All right, good. So let's go ahead, move this up, way up here. I'm going to start at the top, and I'm going to come down. Whoop, passed it up. There is the very top of the graph. It's located at 2. I'm going to ask myself, is that point filled in? No, it's not. So there's my range. All right. So now let's go ahead and determine if this is a function, which by now you should be able to start looking at these and be like, function, not a function. Shouldn't take you more than a second. You'll get there. All right, let me run my pencil across, looking for any time it touches twice. I did not witness that, so this is definitely a test. Now, number 3 is a little bit different. This is a little bit more difficult, and this is where they like to trick folks. Don't be tricked. So anytime your domain or range, the furthest left, furthest right, furthest up, furthest down, has an arrow, that is some kind of infinity, okay? Now, for example, over here, this arrow would head out in this direction, okay? So that would mean that is negative infinity for the x's, positive infinity for the y's. This arrow over here would head out in that direction. That's positive infinity for the x's, positive infinity for y. I know that's an unusual concept. Just give it time to kind of marinate, okay? So first thing, let's go ahead and take a look at my domain x's. All right, let me go ahead and draw in my pencil here. Oh, excuse me, I forgot. Is this continuous or discrete? It is continuous, so I'm going to go ahead and write in the base part of my domain and range. Then I'm going to go ahead and grab my pencil. I'm going to go ahead and move from way out here. I'm going to see what is the smallest x value. Okay, so it looks like it's right around -4.5, but the graph does not stop there. It has an arrow, so it keeps going. So what I'm going to do is I'm going to say, well, it's going to head off in that direction, and in that direction is negative infinity. Negative infinity. Okay. Never, ever with negative infinity do you write in the symbol. it's not even a real number. It just means it goes on forever, okay? So I'm going to go ahead and take my pencil again. I'm going to run it all the way across the graph. I'm going to come out here. I'm going to start backing up. I'm going to see what is the furthest point to the right. And it looks like 3.5. However, again, we have another arrow that's going to be heading out in that direction. So I'm going to ask myself, in that direction, what happens to x? Well, it turns into positive infinity. Okay, so what in the world does that mean? This statement right here is the same thing as saying all real numbers. Some people also use this symbol. What does that mean, though? That just means x can be anybody and anything he wants to be. He has zero limit. He can be whatever number he wants. Okay, so let's clear this up. And let's go ahead and deal with this range. All right, so I'm going to go ahead and highlight my y-axis. I'm going to take my pencil, and of course, because we're starting from the lowest point with y's, we're going to start over here at the bottom. I'm going to go up, 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 and I hit the graph right there. That's a weird place. So I'm just going to call that negative 6.5. I look at that. Do I see any holes? Nope. So it's an extra line. All right, let's go ahead and go to the top. I'm going to come down, 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 down. And it hits both of those at y equals 10. However, these are both arrows. So that means they're going to keep on going in that direction. And it looks like in that direction, y is getting bigger, more positive. So I will call that positive infinity. That means that y can be any number it wants to be, but it's got to be negative 6.5 or bigger. Sometimes people will also write this like this. They just flip it around, and they don't include the infinity. Okay, so we got that. I know that's a difficult concept. Of course, if you need help, you can just ask for it. So let's ask if it's a function or not. Let's go ahead and put my pencil back down. I'm going to drag it across. Let me see if it touches any times. More than once. Nope, it does not. So it's definitely a function. It passes my vertical line test. Alrighty. So I want you guys to go ahead and work on these, and we'll be collecting these answers next time. Thanks so much for paying attention, and see you next time.